light has dual character. What does that mean? That means some of the properties of light can be explained by looking at wave properties, and some properties are only explained if we assume that light is particles composed of package of energy, and these were called photons. So let's see how Bohr tried to explain the observation of the line of a spectrum, these line of a spectrum of hydrogen. He was actually able to calculate and come up with a formula for every one of these lines. So, as we said, electron can only have a specific amount of energy. They don't accept all energy packages. They are very selective to absorption of energy, and this was defined as absorption of energy is quantized, or energy itself is quantized, and it comes into packages of energy. And when light is emitted, these lines which are observed are simply because of electrons dropping from higher energy to lower energy. So he came with amazing mathematical calculation that he was able to define amount of energy of hydrogen electrons. He says, in hydrogen atom, there are different energy levels. You know, if I look at this atom, this is n equal to 1 proton. And then there is n equal to 2 and n equal to 3. Although second and third energy level are empty in hydrogen because hydrogen has got 1 electron, but he can calculate all these different energy. N is right here, principal quantum number. And by placing n equal to 1, n equal to 2, n equal to 3, he calculates the energy of different levels that electron can take. As I said before, although these energy levels, second and third and fourth and fifth, they are all empty. However, they are defining where electron can go if there was energy given to electrons. So electron, there is a defined part of the space for energy of electrons. And as I said, n is 1 or 2 or 3. So by using calculations, they come up with the value of this constant. And the value of this constant, RH, is 2.18 times 10 to minus 18 joule of energy. And if we use this formula, let me erase my whiteboard. And this is a better picture showing hydrogen atom, 1 proton in the nucleus. And then this is the first shell. This is the second shell. And this is the third shell of energy for electrons. And he said electrons are excited when they absorb light or they absorb heat or there is high voltage. They go to higher energy level, let's say E. When they drop, they are releasing energy, and this energy is going to have different wavelengths, as a result, different colors. As far as we can see, this is only talking about visible spectrum of hydrogen atom. So he says when we are applying energy to hydrogen atom is absorbing the energy, and electrons in different hydrogen atoms can be excited to different energy level. This is the first shell, second shell, third shell, fourth shell, 5 shell. So you have lots of hydrogen atom, different packages of energy is coming in. Some electrons have gone to 5th energy level, and some has gone to 3rd energy level. When the electrons go to higher energy level, the atom is called excited. That means it's not very stable. It's going to release the energy to come back to the stable state. We call that relaxation. If an electron is jumping from 3rd level to 1st level, do you see the spacing is larger? But the energy which is released, and we said energy of the light, energy of the photon which is emitted is equal to Planck constant times nu. So the value of nu is going to be larger relative to energy released when atoms, well, let's say what I have here, relative to energy which is released when electrons are dropping from 5th level to 4th level. So this is also releasing a photon emitting light, which is h times nu. H is constant. So do you see frequency is going to be smaller here because energy is smaller? Larger frequency because energy gap is larger. So you're going to have different frequency of light emitted. That means also different wavelengths of light emitted. So every one of those lines, every one of those wavelengths is referring to certain transition of electrons. Electrons dropping from 5th level to 4th level, releasing lower frequency, lower energy emission. And a line which is showing dropping of electrons from 3rd level to 1st level, which is going to have larger energy gap, larger frequency, and different colors. So emission of light because of electrons dropping to lower energy level. Emission of light because electrons are dropping from 3rd level to 1st level. Do you see different colors? Why? Because different photons, different package of energy. So what we are seeing is only visible light. Visible light, based on calculation of Bohr, they are called Balmer series. And this is the only visible light that we are seeing. The other lines we can't see. And based on his calculation, all the visible light, the 4 lines that we are seeing, is result of electrons dropping from the 6th energy level and higher to 2nd energy level, or dropping from 5th energy level to 2nd, or dropping from 4th energy level, or 3rd energy level to 2nd. So these are all transition of higher energy level electrons dropping to 2nd energy level, this 2nd shell. And then if you use ultraviolet detector, you can see there are ultraviolet emissions, and they are all because of the fact that electrons are dropping all from higher energy state to 1st shell. And then you also see infrared lines, which are called Pascan. And Pascan is these emissions, Pascans. All the higher energy electrons dropping to 3rd energy level. Do you see Pascans? They're all, do you see these dropping from 6, 7, they are called infinite. From 6, 7, dropping to here, 3rd energy level. This is 3rd, this is 2nd, and this is 1st. So different lines, simply for due to the transmission of electrons. Electrons dropping from higher energy state to lower. This is only the Balmer series that we are seeing. Red line here. Green line. Blue line. And violet line. Where is violet color coming from? you see dropping of electrons from the 6th energy level, n equal to 6, to 2nd energy level, which is n equal to 2. That's amazing. Amazing understanding of atoms using mathematical formulas.